So we have fractions being divided. So we invert and multiply. We flip the second fraction over and change to multiplying. So you can multiply if you want, or you can start canceling. Either way is okay, because a lot of it's going to cancel. Since there's no adding or subtracting going on, you can start canceling. As soon as everything's all multiplying together, that's when you're ready to cancel common factors. So I think actually most of my students multiply first, then cancel, so I'll do that also. So if you're multiplying, 9 and 2 is 18. 2 times 2 is, a times a is a squared. B to the 4th times b to the 4th is b to the 8th, okay, because you have 4 b's times 4 more b's, so that's 8 b's multiplying together. 3 times 6 is 18. A squared times a squared is a to the 4th, because that's 4 a's multiplying together. 2 a's and then 2 more a's, and then b cubed. So b times b times b, b cubed. So the 18's cancel. And then, see, you have a times a in the top, and a times a times a times a in the bottom. And so the 2 a's divide away, and you just have a squared left in the denominator. In the numerator, I'm not going to write out 8 a's and 3 b's. I'll just say that there's 8 b's multiplying together on top and 3 b's on the bottom, so you get b to the 5th when you divide away 3 of those b's. So this one is b to the 5th over a squared. So you add exponents to multiply. Okay, you add exponents to multiply, and then you subtract exponents to divide. Or you can write them all out like I did with the a's, and then you can see how that's happening. Then you can see the division going on and see how the multiplying is going on as well. Let's see. And then we have number 18. Divide using long division. So since we're dividing using long division, we'll set this up using long division. And you notice we don't have a y, just plain y. We have y cubed and y squared, but we don't have a plain y. So we'll put a 0y in for a placeholder on this problem. So we'll put the 5y minus 5 here, 25y cubed minus 10y squared plus 0y plus 2. And then off to the side, we do the division, 25y cubed divided by 5y. So that's 5y squared. So we'll put 5y squared in our answer. And then we take the 5y squared times each of these terms. So 5y squared times 5y is 25y cubed. And 5y squared times negative 5 is negative 25y squared. And then we subtract. So the 25y cubed minus 25y cubed is 0. And here you get a minus a negative, so you get plus. So negative 10y squared plus 25y squared. So that's 15y squared. Then you can bring down the next term. And start over. So off to the side, we'll take the 15y squared divided by 5y. Get 3y. So I'll put plus 3y. Then take the 3y and distribute it. So 3y times 5y is 15y squared. And 3y times negative 5 is negative 15y. So that's what we're subtracting. So the 15y squared subtract away, but we get a negative 15y, so that's positive 15y. And bring down the 2. So for the 15y plus 2, we'll take the 15y and divide by 5y off to the side. And that's 3. So I'll put plus 3 here. And then 3 times 5y minus 5. So 15y minus 15. And subtract. And be careful with your subtracting. So we get 2 minus negative 15. So that's 2 plus 15 or 17. So we take our remainder, the 17, and we write it as part of our answer. So 17 over 5y minus 5. So make sure you fill in the missing term and be real careful with your subtraction. Okay, so make sure you get the signs right as you subtract. Let's see. I also got sent number 13. So this looks a lot like the one we just did, but it doesn't say to use long division. The only time you use long division is when the problem says to use long division, because it's harder than other forms of simplifying. So go ahead and factor and reduce. In the numerator, you have the difference of squares. So we factor as 1 minus 5a times 1 plus 5a. So those are 1 is the 1 squared, 25 is the 5 squared. And then in the denominator, we also have squares, a 25 and a 1 again. So we use guess and check. Okay, so if your first and last terms are perfect squares, try guess and check. So we're going to use the 5a and the 1. And then use your signs right here. Okay, so if the last term is positive, then you need 2 negatives multiplying together. So that was the guess. And now we check. So first terms, 25a squared. Outer terms, negative 5a. Inner terms, negative 5a. And last 1. Is that what we started with? Yeah. Okay, so the check worked out. But nothing cancels. Remember, if you go and look at your problem and you have opposite signs, so here on the top I have a positive 1, on the bottom I have a negative 1. On the top I have a negative 5a, and on the bottom a positive 5a. You can factor a negative 1 out of one of those factors, so like out of the numerator, for example. So if I factor out a negative 1, that leaves a positive 5a and a negative 1. Doesn't change the second factor. The 1 plus 5a stays the same. But now if I were to distribute the negative 1, you see how I get back what I started? I'd have a negative 5a and a positive 1 that I started with. So when you factor, you always want to be able to multiply out and get back what you started. That's your check. Okay, but now I can cancel the 5a minus 1. So negative 1 times 1 plus 5a over 5a minus 1. Let's see. Then there was another difference quotient problem, 17a. actually, I guess the question's only about, yeah, A. Okay, so find f of x plus h minus f of x over h. So I'll put the x plus h in for x. Okay, so first I'll find f of x plus h. Okay, so remember what that means. That means plug in x plus h for the x here. So you have 2 parentheses x plus h squared.
Oh, I'm kind of confused about that.
So function notation, whatever's in these parentheses, you put in for the x right here. So instead of x being squared, it's the x plus h being squared, because that's what's in the parentheses.
Oh, okay.
So you work that part first, and then you put it in right here. Okay, so let's see what that looks like then. X plus h times x plus h. I got kind of crowded, so I'll go up. So first terms would be x squared, and the inners and outer terms would each be xh. So there's 2 xh's, one from the inners and one from the outers. And then last would be h squared. So we're multiplying out using FOIL. And then you can distribute the 2. So we have 2x squared plus 4xh plus 2h squared. So that's the part that's the f of x plus h. So we'll write that down. 2x squared plus 4xh plus 2h squared. And then I'll subtract f of x. So f of x you put in parentheses. So we'll put 2x squared in parentheses. And the h was already there. So we find the f of x plus h separate, and we filled it in right here. So in red, f of x plus h part. And then in blue, the f of x part. So after you fill in the template there, then you can subtract, and the 2x squared subtract. So you have 4xh plus 2h squared over h. And you can split that up since the denominator is just one term. So when the denominator is one term, you can split up your numerator like that. And then you can reduce that way, or you can factor off a h. 2 different ways to reduce on that problem. Any questions on any of those steps? This part takes a lot of practice. Okay, so maybe practice that extra. Let's see if any of the questions that I got are quick. Let's see. Let's try 16. 16 looks interesting. So in 16, you have 4 terms in the numerator, and you're supposed to, it says divide by factoring the numerator and then dividing out the common factor. So there's 4 terms. That means you should factor by grouping. So x cubed plus 2x squared, the greatest common factor on those 2 terms is x squared. On the second 2 terms, the greatest common factor is negative 25. And that leaves a positive x plus 2 behind. So now we have 2 terms, and they each have x plus 2, so you can factor the x plus 2 off. So that leaves x squared minus 25 then. You still can't like divide out the 5 and the x because the minus sign means the whole factor has to match before you can cancel. You can't cancel part of the sum or part of the difference. That's okay. We'll just factor the x squared minus 25. So the x squared minus 25 factors as x plus 5 times x minus 5 conjugates. And you can cancel the x minus 5s. If you want, you can write a 1 in the denominator, but when the 1's in the denominator, you don't have to write it out. Well, I'll try and get some more of these in after class. So we'll go on with today's work. Oh, I have a note for myself to tell you. There is a special drop-in tutoring session next week in the evening. So if you find Tuesdays from 8 to 10 p.m. a good time for you to drop in and get some studying help, it's going to be in the library. And you're supposed to ask a librarian for Jake. So Jake will have a table up there. Usually he's in the math suite on Tuesdays and Thursdays from 10:30 to 12, 10:30 to 12:30. So if that's a good time, then you can see him any week. The math suite?
Where was that? Where's the math suite?
Tuesday to Thursday, ES 323E. So in the ES building in 323E, 10:30 to 12:30. So this is every week, as long as students keep showing up. If he's sitting there for a while, after a week or two, they'll pull him out. So it's good if some of you can stop in once in a while so that he doesn't get removed right when you need his help. Okay. Anybody have any questions? Okay. Well, let's continue then in 6.4. We're looking at addition of rational expressions. So adding fractions is harder than multiplying or dividing. Multiplying and dividing turned out to be a lot of factoring and canceling, which isn't the easiest, but it's at least building on something you know. When you add fractions, you have to have the same denominator. Okay, so that's what it says up here. Fractions must have the same denominator to be added. So we were looking at the prime factorization method of finding the least common denominator. So we take the 24 and factor it. So 24 is even, so it's 2 times 12. 12 is even, so it's 2 times 6. 6 is even, it's 2 times 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. Eighteen's prime factorization, that'd be 2 times 9, and 9 is 3 times 3. There's only one prime factorization for a number, so if you started out as, 24 is 4 times 6, eventually you get to the same prime factorization as I did. So the least common denominator then is the smallest product that contains both denominators. So just write one of the products down. So I'll just pick the first one, 2 times 2 times 2 times 3. And then examine it and see what it does not have that the other denominator does. So the other denominator has a 2. I got a 2. The other denominator has 2 3s, 3 times 3. I only have 1 3, so I'll put another 3. Okay, so the least common denominator is the smallest denominator that contains all the other denominators as factors. So here's the 2 times 2 times 3 from the one denominator, and here's the 2 times 3 times 3 from the other. So that's not the only way when you have numbers, but that's what we're going to use when we have polynomials. So we're getting some practice in. What is that? 8 times 9? 72. So I have to build up my fractions, and I already found the 24 needs a 3 to get a 72, because this was my 24. 24 times 3 is 72. So I'll take my 1/24th. I'll take the 1/24th, and I'll multiply by 3/3. And then my 18, that's 2 times 3 times 3, so I need 4, 2 times 2 yet. So I need to multiply by 4 over 4. So we have 3 over 72 plus 4 over 72, and that's 7 over 72. So fractions must have the same denominators to be added, and then once you have the same denominators, then you add the numerators. Because then you're adding the same size things. You're saying how many of these are there that are each 1/72 of a pizza large. That's how big they are. Little tiny slice of pizza, 1/72 of a pizza. And there's 3 plus 4 is 7 of those. So we'll find the least common denominator by looking at the prime factorization. So this first denominator on the next problem is 3 times y. And the denominator on the second fraction is x times y. So the least common denominator will be the smallest product that contains both denominators. So you just write 1 down automatically. So I'll just write the 3 times y. And then I look at the other denominator and say, okay, I already wrote the y down, but I didn't write the x. So I'll say times x. So 3xy is the least common denominator that contains the 3y, and it contains the xy. Okay? Okay, so let's build up our fractions. Let's take the 5 over 3y and multiply it by x over x. So we're multiplying 5 over 3y by x over x. And we're multiplying 2 over xy by 3 over 3, because we want it to get a least common denominator. So we have 5x over 3xy minus 6 over 3xy. So both denominators are now 3xy. So you can go ahead and do the subtraction in the numerator. So 5x minus 6 over 3xy. So fractions have to have the same denominators to be added or subtracted. The least common denominator is the smallest product. Okay, product means multiplying, so the smallest stuff multiplying together that contains each denominator as a factor. So as we're building up our fractions, remember the reason we do that is because we're multiplying by 1. In algebra, a lot of algebra is just rewriting stuff so that it's equivalent but written differently. So you want stuff to stay equal as you rewrite it. And if you take something and multiply it by 1, it stays equal to what it was already. Does anybody have any questions? Okay. So we're going to be checking the denominators to see if they factor. And a sum in a denominator is a distinct factor in a least common denominator. What we mean by that, let's look at our denominators. Okay, so first denominator, x minus 1. Second denominator, what is the denominator for 3? 1. Good. Okay, that's 1. And third denominator is x squared, which is x times x. The sum means adding or subtracting, okay, because we can add negatives. Okay, the sum, x minus 1, is distinct. It is not the same as this x over here. So when we're looking at the least common denominator, the x minus 1 goes in parentheses as its own little factor. You can put the 1 down if you want, but 1 times x minus 1 is still x minus 1, so you don't have to put the 1 down if you don't want to. And then you need the x times x, or the x squared. So the least common denominator is x squared times x minus 1 on this problem. Okay, so it's the smallest product that contains each of the other denominators, making sure you notice that the x in this x minus 1 is not the same as these x's. And that's because as you're trying to build up your fraction, you're trying to get x minus 1 over here. Well, you can't get it without using the whole x minus 1. And you're trying to get an x squared over here, and you can't have the x squared and the x minus 1 here without leaving the x minus 1 the way it is. Okay, anyway, let's build up each of these fractions so it has x squared times x minus 1 for its denominator. So first we'll multiply here by x squared. So multiply the first fraction by x squared over x squared. And then the 3, we'll multiply the 3 by the whole least common denominator over itself. So x squared times x minus 1, x squared times x minus 1. And then that brings us to the negative 4 over x squared. So we'll multiply there by x minus 1 over x minus 1. So our least common denominator contained all the denominators as factors. And now we can build up our fractions so they all have that least common denominator. So the denominators you just leave, but the numerators multiply out. Maybe we should make a note of that. Leave denominators factored. Leave the denominators factored, multiply out numerators. Leave the denominators, remember D for denominator, D for down, okay? So leave that denominator factored, but multiply out the numerator. Okay, so here I'd get x cubed plus 2x squared. In the second term, you have a 3x squared to distribute. So 3x squared, you'll have to multiply that out times x minus 1. You could do that in one step if it's easier for you, or if it's too much going on, just wait and do it in another step. And then we're going to subtract. We'll have x squared times x minus 1. And in the numerator, I distribute the 4. So you have a 4x minus 4. So now you can add the numerators together because all the denominators match. Okay, so you're going to have all the numerators together over x squared times x minus 1 because they're all matching denominators, so you can add the numerators together. So we have x cubed plus 2x squared. Let's distribute the 3x squared while we're adding here. So 3x cubed minus 3x squared, and then the minus distributes, so be careful with the minus, okay? So you get a minus 4x and a plus 4. So we multiplied out the numerators so that we could actually do some adding here, because now we'll have some like terms that we can combine. We have 4x cubed minus x squared minus 4x, and then plus plus 4 because of the minus and negative, so you have plus 4.
I have a question. I don't know how to really describe it, but yes, that equation right next to it. On the denominator, the x squared, x plus 1.
Oh, it's supposed to be minus. Yeah, thank you. No, that's a good eye, good eye. Yeah, see the error there. Okay. Any questions? We should check and see if we can factor and cancel anything. So this would be factoring by grouping if we can factor. So I'd have an x squared times to factor off the first two terms. And on the second two terms, I could factor off a 4 or a negative 4. So I won't be able to keep factoring by grouping because these don't match, these binomials. So don't match. They don't match. Okay, so if the binomials don't match, then you can't keep factoring. And so just, you can forget the numerator factoring. So this is your answer. So we're just building up our fractions so they all have the same denominators. So on this next one, your first denominator is a plus 2. Your other denominator is a. Can you write down the least common denominator, please? Does anybody want to tell what the least common denominator is? Almost. Good. Okay, so a times a plus 2, because the sum a plus 2 is a separate factor. It's distinct from the a. Okay, can you go ahead and build up your fractions and then add them together, please? Or actually subtract in this case? So you should have taken the first fraction times a over a to get an a into its denominator. And then the second fraction times a plus 2 over a plus 2 to get a plus 2 into its denominator. And then both denominators are a times a plus 2. So you can do the subtraction. So as you're writing them down in the numerators, you multiply out. Okay, so you have a 3a and a 4a plus 8. And then when you subtract, the minus extends to both terms when you actually subtract. So you get 3a minus 4a minus 8, which is negative a minus 8 in the numerator. Okay, so the whole goal on these is to start with this and finish with this, and they are equal in value. So if you plug the number in for a up here and compared it to the number that you put in here, you get the same thing. So for example, just pick a as 1. Then you'd have 3 halves minus 4. And if a is 1 down here, you'd have negative 9 over 1 times 3. A is 1. I just picked the number randomly. Oh, yeah, okay, thanks. Okay. Why isn't that working? Okay, so we have 1 minus 4 is negative 3, which is in fact what we have here, okay? So we're just rearranging. That's what a lot of algebra is. You're rewriting so that you have the same thing at the beginning as you do at the end, but it's rearranged differently for different reasons. One reason you would do this is to see when your expression equals 0 or when it's undefined. It's a lot easier to see when this equals 0 at the end and when it's undefined than it is at the set right up here. And those are usually important parts of a problem. Where is this problem undefined, or where is this problem 0? So for example, here you can see this is 0 when a is negative 8. So then you get 0 in the numerator. All right, anyway, that's why you might want to do that. Well, a lot of these you'll find you'll have to factor and cancel. So let's go ahead and work on, did I say factor and cancel? You'll have to factor before you find the least common denominator, which is what we were doing at the beginning. You know, we were factoring. That's what you have to do here. Okay, so factor your denominators first, if you can. So the first denominator is the difference of squares. So it's x plus 3 times x minus 3. And then the second denominator is x plus 3. So the least common denominator is the smallest product that contains both of those. So if you have the x plus 3 times x minus 3, well, that contains the whole first denominator. And it also contains the second denominator. Okay. So the least common denominator has the whole left denominator, and it has the whole right denominator. So you can go ahead and build up your fractions now to get this least common denominator.
How come you wouldn't have to take the whole thing times the exponent of the second?
So you only have to have this this denominator showing in it somewhere.
Okay.
So it doesn't have to be in addition to, it just has to be in there somewhere. Any other questions? Okay. So we have 3 over x plus 3 times x minus 3. Minus 4 over x plus 3. So the second fraction needs to be built up. So we need the x minus 3. So we have 3 over x plus 3 times x minus 3. And then I'll multiply out the numerators. So 4 times x, and 4 times negative 3 is negative 12. So 4x minus 12. So multiply out the numerators and leave the denominators factored. That way if something cancels later, we can. Yes? In the next step it will be, yeah. So if you're doing two steps at once, that's good. So the minus, so if you want to change it to a plus right away and then change this to minus and that to plus, that'd be good. So 3 minus 4x plus 12. Is that what you were thinking? Yeah, okay, good. Okay, so the numerator is all multiplied out and subtracted, so you can go ahead and add like terms together. We have 15 minus 4x. And then we just kind of look and see, can we factor our numerator, but it doesn't look like it, so we're good. So whenever we see a denominator with a squaring in it, we think about, can we factor and cancel? I mean, can we factor and find our least common denominator after factoring? So first denominator, we have m squared. So if we can factor it, it will be m and m in the first positions. And then a negative 6, so two numbers that multiply to negative 6 and add to 1. Plus 3 minus 2. And then the second denominator is m times m minus 2. So the least common denominator is the smallest product that contains both of these denominators as factors. So we have the m plus 3. We just automatically write one of the denominators down. So I just wrote the m plus 3 times m minus 2. And then looking at the second denominator, I have an m minus 2 written already, but I don't have that m written, so that m has to get written in. Okay, so I have the first denominator right here, and then the second denominator is right here, m times m minus 2. So we just build up our fractions till they each have that denominator. Can you go ahead and do that? Can you see if you can build up those fractions and do the adding? So you build up the first fraction by multiplying by m over m, and the second by multiplying by m plus 3 over m plus 3. So the m in the first fraction distributes, your m squared minus m in the numerator. And in the second fraction, your numerator becomes 3m plus 9. So you go ahead and distribute those, and then you can add those numerators up. So when you add them all up, you get m squared plus 2m plus 9 all over your denominator. Don't lose your denominator. For some reason, some students lose their denominators. Because, again, we have to have what we started with equal to what we ended with, just written differently. Anybody have any questions? Okay, I think we're going to skip the next one on page 17 on page 77 on the top, because I want to get to somewhere we have some negatives, where we have opposites. So if you look at this bottom of page 77, you have a positive m and a negative m and a negative 3 and a positive 3. So when you see that happening, go ahead and factor a negative 1 out of here. So if you factor a negative 1 out, that leaves the opposite signs. So you have a negative m before, and now you have a positive m. And you had a positive 3, now you have a negative 3. And this negative cancel, so you get plus. So your least common denominator is just m minus 3. It doesn't have to be m minus 3 times negative m plus 3. You can just go ahead and take care of having the smallest least common denominator possible. That's why it's called least. As small as possible. Okay, so you can then add these up. So 2 plus p over m minus 3. I have a little note there. When you have a negative in a fraction, you can write it to the left, or in the numerator, or in the denominator. So, for example, on this negative 1, if we wanted to, we could have moved it to the top. So when you have a negative in a fraction, you can write it in 3 different places. Does anyone have questions? I think that's what's going on in this next problem, too. Okay. So I want to have time to get to the WebAssign problem, so this one will go to the bottom of the page 78 also. So let's factor our denominator. So the first denominator factors. So because we start with an x squared, you can have x times x for the first terms. And then negative 5, you can write that as a positive times a negative. So we'll pick positive 5 times negative 1. And then if you're looking at your other denominator, you have a 1 minus x. Well, that's the opposite, because here I have a positive 1, and here I have a negative 1. Here I have a negative x, and here I have a positive x. So on my second denominator, I'm going to factor a negative 1 out and write x minus 1. Okay, so factoring out a negative makes the x positive and the 1 negative. And I'm not going to keep that negative in my denominator. I'm going to rewrite this as plus. So what I'm trying to say is what we have here is x plus 3 over x plus 5 times x minus 1. And then I have a x minus 4 over a negative 1 times x minus 1. But I can make the two negatives cancel. Okay, so when you're subtracting something that's negative, it's the same as adding. So that makes our least common denominator smaller. Okay, it's just x plus 5 times x minus 1. Okay, so let's build up the second fraction. The first fraction is good. The first fraction has the least common denominator, but the second fraction needs an x plus 5. So we'll multiply by x plus 5 over x plus 5. So we have the x plus 3 that we start with. And then let's just write LCD for least common denominator. And then in the second numerator, we multiply out. We get x squared plus 5x from the outers minus 4x from the inners minus 20. So you can add all of that up. So when you add that all up, we have the x squared. 5x minus 4x is 1x, and then this x, so 2x. And then 3 minus 20 is negative 17. So we'll be watching for having the opposite factor because you want the least common denominator possible. It makes the rest of the problem easier. So if you have opposite factors and you can get a negative 1 out, that makes your least common denominator smaller. Well, I'll let you go, and I'll put this last one on video. So when you're doing WebAssign and you get to number 16, if you want an example, you can turn on the video and look at it, okay? So do not ask me number 16 in class. Not if you don't look at the video anyway. If you look at the video, then you can. And we didn't, the one at the bottom of the page, you don't have to know that one. All the denominators factor, so I have them factored out, and the least common denominator will be the smallest product that contains all of those. So I'll just write the first one down. And then looking at the second one, I already wrote the x plus 4 down, but I need the x plus 7. And looking at the third one, I wrote down x plus 6 and x plus 7 already. So the least common denominator is written down there. So we'll build up all of the fractions so they have that least common denominator. So the first one I'll multiply by x plus 7 over x plus 7. Maybe I'll just take time to write the fractions down and leave some space for the building up the fractions. Just write the fractions down, and then we'll build them each up. Now you're going to have to put parentheses around your numerator because those are sums and they're going to be multiplied. So you have to put parentheses around your numerator. Okay, and the first fraction needs to be built up by multiplying by x plus 7 over x plus 7. The second one by multiplying by x plus 6 over x plus 6. And the last one by x plus 4 over x plus 4. So we'll multiply out all these numerators. So we get 2x squared for the first terms, plus 14x, plus 6x, plus 42. And we'll just say LCD for now. And check your arithmetic. And then in the second numerator, you have x squared plus 6x plus 1x plus 6 all over the LCD. And the third numerator, you have x squared plus 4x plus 8x plus 32 all over the LCD, and then just check the arithmetic. Okay. So all of these need to be combined, added, and subtracted. Actually subtracted, right? So as you subtract, make sure the minus sign extends to each term. We have a lot going on. We have the 2x squared plus, let's just add those up, 20x plus 42, and then distributing, so minus x squared, and then the 6x and 1x is 7x, so minus 7x, minus 6, and another minus x squared, and then 4x plus 8x is 12x, so minus 12x, minus 32. So all of those are being subtracted. So a lot of students will make an error there, so be careful with your subtraction. Okay, well, what do we get when we add these all up? We get x squared adding to 0, 20x minus 7x minus 12x. So that's just x. 42 minus 6 minus 32. So that's 4. So this is carefully crafted so that the numerator you get is just one of your factors. And so in this case, it divides. So that was a lot of work. Be careful with your subtraction. I'm going to go ahead and answer some of these other emails that I got. Do either of you have questions? Go over it. Oh, number 6. Oh, I'll do that one. Can you tell me your name, please? Okay, so looking at number 6. Okay, let me just double check that I wrote it down right. So this is an 11AB right there. So I'll go ahead and flip this last fraction over and change to multiplying. Okay, so dividing means flip and multiply, and then instead of actually distributing anything, we see if we can factor and cancel. Okay, so we have all of these multiplying together, but we're going to factor and cancel, hopefully. This one starts with a squared, so we can factor it with a, and then you have plus 36 and minus 12. So we'll need two negatives multiplying to be positive 36. So I'm going to say negative 6b, negative 6b. The first denominator is the difference of squares. So we can factor as a plus 5b and a minus 5b. And then the next numerator, we'll just extend our fraction bar now because we're going to have everything all multiplying together. We start with a squared, so a, and then two numbers that multiply to positive 30 and add to negative 11. They're going to have to be two negatives multiplying to be a positive. So we'll have 6b and 5b. And then you notice how your inners and outers, you get negative 6ab and negative 5ab, so you get the ab in there. The denominator, a minus 6b squared, we just write a minus 6b times a minus 6b. And then extend your fraction bar to the last fraction. So the a squared you can write as a times a. And the negative 30b, we would have a negative 6b and a positive 5b. Because then those negative 6 and positive 5 add to negative 1. The denominator is the difference of squares. So you can factor as a plus 6b times a minus 6b. So a lot of factoring and then hopefully a lot of canceling. So here's an a minus 6b and an a minus 6b. Another a minus 6b and a minus 6b. A minus 5b, a minus 5b. A minus 6b, a minus 6b. A plus 5b, a plus 5b. So this one turned out to be a minus 6b over a plus 6b. Any other questions?